Hello everybody, welcome to my channel. This channel is going to be focusing on an incremental approach to beginning calculus. And since calculus builds on a lot of different types of math, I do believe it is important to have a good fundamental basis of algebra. So over here we are looking at the unit circle, and it is super important to know your values and if needed, if you forget your values, to be able to derive them. So first, we're going to fill out all the values in radians. So the first, as you know, is 30 degrees, but we are going to write that as pi over 6. The next value we have is pi over 4, and then the next is pi over 3. And then over here along the y-axis, we have pi over 2. Then we have pi over 3, right over here is going to be 2 pi over 3. This is pi over 4, this is 2 pi over 4, and this is 3 pi over 4. And then we have pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, and 5 pi over 6. Over here along the x-axis, we have the value pi, which as you know, translates to 180 degrees. So far, all of our values are correct. 5 pi over 6, 6 pi over 6, 7 pi over 6. 3 pi over 4, 4 pi over 4, 5 pi over 4. 2 pi over 3, 3 pi over 3, 4 pi over 3. Pi over 2, pi, 3 pi over 2. 4 pi over 3, 5 pi over 3. 5 pi over 4, 6 pi over 4, 7 pi over 4. 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. And then lastly, along the x-axis, we have positive 2 pi. So as you can see, I filled out some other important information. Something that you do need to know is the signs, not the S-I-N-E-S, but the S-I-G-N-S of the different quadrants. So with the first quadrant, both sine and cosine are going to be positive. For the second quadrant, cosine is going to be negative and sine is going to be positive. The third quadrant, both are going to be negative. In the fourth quadrant, cosine will be positive and sine will be negative. Great. This is something that you are especially going to need to know when we were looking for our tangent values. So we know the sign of our tangent values. So now what we need to do is really the most important part of it all is finding our sine and cosine values for our specific radian angles. So what we are going to use is these angle identities, saying the 30, 60, 90 and the 45, 45, 90. But these are in degrees, and as I said earlier, we will be trying to move away from degrees and we will try to use radians more. So we do need to know how to convert our radian measurements to degrees. And later you will be able to just in your head know automatically what values the radian measures correspond to. So let's create a simple ratio. What we know is pi over 6. That's what we have, right? Then also, something that we know is that pi is equal to 180 degrees, which you can see right here. So what we want to do is create a simple ratio. If pi is equal to 180 degrees, then pi over 6 is equal to x degrees. So let's just cross multiply. So we have 180 pi over 6 equals pi x. Next, we're just going to simplify here. We have 30 pi equals pi x. Again, divide the pi's. We have x equals 30 degrees. So now you've successfully converted your radian measurement to a degree measurement. But this is difficult, and as we're starting out, you do not want to have to do this every single time. So there is an easier way to do it. The way that you translate is simply by saying pi over 6 times 180 over pi radians. And as you can see, that is essentially what we did here. We are just taking away these ratio and cross multiplying steps. So that is just what you need to know. Okay, going back to finding the values. We have pi over 6. Pi over 6, like we just found out, is equal to 30 degrees. We will be using these identities. So as you can see, we dropped it down and created a right triangle. It was not originally there, but we created one, which is allowed in math. We have a 90 degree, and we have 30 degrees, which is what we found. Now, what makes the unit circle the unit circle? That it has a radius of 1. That is how we know that it is the unit circle. So over here, by using these identities, we know that the hypotenuse is equal to 2x. So then we know that the smallest side of the triangle will be 2x divided by 2, or just x. So now we know, and the smallest side is going to be the side opposite the smallest angle. So it will be the side opposite the 30 degrees. So we will have 1/2. Now, 1/2 is our x value, and the second largest value in the triangle will be x times root 3, or 1/2 times root 3, or root 3 over 2. Great, now we have a fully filled out triangle. And as you know, cosine is equal to the x values, and sine is equal to the y values. So what we have is cosine or x, root 3 over 2, sine or y at 1/2. Great. Now let's fill out pi over 4. If we do pi over 4 times 180 over pi radians, these will cross out. 180 will be divided by 4, which is 45 degrees. So next, let's drop down for this triangle over here. I'm going to have a 45, 45, 90 triangle. Again, the radius will be 1. If 1 is equal to x root 2, then what is x? We just need to divide by root 2. So we have 1 over root 2 and 1 over root 2. Some teachers prefer you to not have a radical in the denominator, so all we have to do is multiply the numerator and denominator by root 2 over root 2. So we just end up with root 2 over 2 and root 2 over 2. So let's fill that into our unit circle. Cosine, root 2 over 2, sine, root 2 over 2. Okay, great. Now let's do pi over 3. First, let's convert it. Pi over 3 times 180 over pi radians. These will cancel out, and 180 will be divided by 3, which is going to give us 60 degrees. Now we're back to the 30, 60, 90 triangle. So we have over here, we dropped a leg down. Our hypotenuse is at 1. We know this angle to be 60 degrees. We know this angle to be 30 degrees and this to be a right angle. So if the hypotenuse is 1, which is 2x, then that means that the smallest side, or the side opposite the smallest angle, will be 2x divided by 2, or x. So we have 1/2. Now the second biggest side will be x times root 3. So 1/2 times root 3 is root 3 over 2. As you can see, because both of these triangles have the same angles, they will also have the same side measurements, just in different places, which is to be expected. So now we know that for pi over 3, cosine is 1/2 and sine is root 3 over 2. Again, we know that because cosine is moving horizontally and sine is along the vertical axis. So now let's look at pi over 2. Pi over 2, let's not make it too complicated. Let's not draw a triangle. Let's just think about what we know. How far is pi over 2 moving across the x-axis? If you said 0, you're correct. So we know that our cosine value is 0. And also, because we know that the radius of a circle, the radius of the unit circle is 1, and we see that this line is going all the way up to the top of the circle to the maximum that it can go, we know that sine is 1. Okay, now I'm going to cut the video and fill in the rest of the sine values. Okay, you can see here that I have filled in the values, and you may be thinking, wait, how did you do that? I don't like that you just skipped through all these parts, but don't worry, it's a lot simpler than I believe your previous math teachers have told you. So all that we're doing is these are our base values. This is really all that you need to know, this first quadrant. And then all you need to do is for the second, third, and fourth quadrants, we're going to look at our corresponding radian values and just translate them to the sign, the correct SI, and S. So for example, let's look at pi over 4. The corresponding value in the second quadrant will be 3 pi over 4. Our sine and cosine magnitudes will be the same. The only thing that will be different will be the SI, and S. So we see here that sine is going to stay the same, and I apologize, my rad 2 over 2 looks a little bit weird, but I promise that says plus rad 2 over 2. It's just a positive rad 2 over 2. But second quadrant tells us, because it is to the left of the y-axis, that cosine will be negative. So we have negative root 2 over 2. So as you can see, I did not derive the values again, I merely changed the signs. So let's look, for example, at pi. We see over here that 2 pi is 1, 0. I found this out the same way that you found out pi over 2, simply by looking at how far, and it moves up or down 0, but it moves to the right the farthest it can, so it will be 1, 0. And then we look over here, we do not have to derive that again because it is to the left of the y-axis. It will be negative 1, but stay the same for the y-plane. Let's look at another one. For example, we have pi over 3. The corresponding value, let's look at it in the third quadrant. The corresponding value will be 4 pi over 3 in the third quadrant. As you can see, the magnitudes for these two angles are the same. The only thing that's changed is the SI, and S. The cosine will be made negative because it is to the left of the y-axis, and the sine will be made negative because it is below the x-axis. I'm sorry, did I say x-axis before? I meant the y-axis. It is to the left of, and it is below the x-axis. So let's look at one more example. Let's look over here. We see 5 pi over 6. The corresponding value in the fourth quadrant will be 11 pi over 6. Or if you want, if we only have the first quadrant, let's look at pi over 6. Pi over 6, the corresponding value is 11 pi over 6. Again, the magnitudes are the same, root 3 over 2 and 1/2. But because we are in the fourth quadrant, we know that cosine will stay the same, so we still have root 3 over 2. But sine will be made negative because it is below the x-axis, so we have negative 1/2. So you've pretty much derived all of your unit circle values. Once you work with this more, you will be able to just think of a value, and you will be able to think of an angle, and the value will pop into your head, and you will not have to rely at all on converting to degree measurements. You will be able to simply rely on the fact that you know the radians. I will have more videos to come working into the beginning calculus theories. Thank you so much, and I hope you learned a lot from this video.